Well, first of all, I want to thank you for inviting me. And this is a room filled with quite amazing people. And I always find it really wonderful when you're around people who like fish. And I'm kind of into that myself. So very interested in the research they saw. I went to the cold regions lab yesterday and was very impressed with what they were doing there too. And also, I'm really privileged to have such high-powered academic staff here too, and to see Alex again is a great pleasure. I spoke yesterday, and I don't know how many of you were there, but I was told that this would probably be a different audience than yesterday. So what I was hoping to do is to cover some of the same ground that I did yesterday by way of introduction, and then we can talk about the policy and other implications that you might see rising from this. But it was really interesting to hear Kyle say that some of you maybe weren't sure what you might expect from today's discussion, and that you came only with an open mind. I sometimes don't deal with audiences that have that quality. I'm from Alberta. I'm sorry. And what I want to go through first, and Alex will certainly appreciate this, is how do you get people who simply don't want to hear the water and climate message to at least listen to it? And so what I wanted to start by introduction today was add to some levity to what perhaps can be, if you were there yesterday, know it can be a very dark subject, and that is our future and how hydroclimatic change might affect our society. And I noticed that all of you are interested in one element of that or another, right from very profound species-specific research right to major policy considerations, etc. So I wanted to say that too. And again, I want to just briefly just mention the UNU. And the reason why I bring that up is because Alex preceded me there. And one of the things that I always seem to be following Alex around, because one of the things that I do in my work is to build a better bridge between science and public understanding and policy action on water and climate issues. And one of the truly important things that we do is to try to bring international example to bear on Canadian water issues. And another thing that we really try to do is to make direct relationships with political decision makers so that there's a direct and immediate avenue. And so science is absolutely critical, and getting that science in the right form at the right time in a policy relevant condition to these people is increasingly a serious issue. And also I think it's pretty clear that in Canada, at least, that water and climate have become really hot issues, and I'm sure most of you would agree with me. Certainly it was interesting to hear the others yesterday speak on this, that it's not easy to inspire the public imagination with an accurate interpretation of the relationship between water and climate. And what we see is that a number of things happened is popular culture got there first, and education notwithstanding, I think we derive a great deal of what we know and what we think we know, not from science directly, but from movies and television. And unfortunately, the information is not accurate. But what I've tried to do here is to take this difficult subject to people who don't want to hear this message by a different avenue. And the avenue I use is looking at the movies that we see. And when I talk about information and accuracy, the example I always use is most of what people presume to know about dinosaurs comes from Jurassic Park. And one of the reasons I think we love films like this so much is that they demonstrate what the future might be like if only we had enough imagination. But if any of you have looked at that film, finding intact 200-million-year-old DNA in amber is not easy to do, as it was in the movie. Nor was getting DNA out of an insect trapped in amber easy to do without contaminating it. And filling in large gaps in genetic strands with frog DNA are not likely to produce a viable genome because their constituents have not evolved together and in fact don't know how to talk to each other. So what I think is really interesting about this is that it's been 22 years since the first Jurassic Park film was made. And these problems remain to be resolved, and it's going to be interesting. It's coming out in June. Go see it. I'm going to see it. And but again, then when you look at this, even if you were successful in implanting DNA into an appropriate egg medium, it would be difficult to overcome development problems associated with gene splicing. And if you're able to hatch the eggs, then there would be additional problems with compatibility with bacterial environments. There would also be challenges with humans replacing parents in behavioral instruction. You know, I can't imagine raising a velociraptor. But also, you notice in Jurassic Park there were a lot of predators, and the number of dinosaurs in Jurassic Park would have required more room than they were provided on Isla Nublar. And that island was too small to provide natural food supplies and also simultaneously prevent habitat destruction. But I do think the movie covered this fairly well, because the dinosaurs were hungry, clearly, and that was evidenced by the fact that they started to eat some of the central characters. And some of you may remember what I thought was utterly the most symbolic scene in the entire movie. I don't know how you feel, but for me there was something deeply satisfying about a dinosaur eating a lawyer. You know? So, and what I also find interesting is that as a consequence perhaps of undersea volcanism caused by sea forest shredding, the concentration of carbon dioxide in the atmosphere in the Jurassic might have been 2,000 parts per million, which would be 5 times what it is today. So it was a much hotter world in which humans would have found it very difficult, if not impossible, to survive. Now, a great majority of people have also learned what they know, or what they think they know about climate change, not directly from science, but from popular books and movies and made-for-television epics that interpret science in an entertaining and an imaginative way. And a great deal of the current interest in climate change emerges from this very highly public debate over whether or not it's actually happening, and if so, what's causing it. And while these matters are certainly very well settled in the scientific community, a very high profile and profitable denial industry has come into existence to create a market for doubt. And one of the real vocal climate deniers that was portrayed in the opening of this film, James Balog's Chasing Ice, was a San Francisco television meteorologist named Brian Sussman. And in 2010, Sussman published a book called Climate Gate. A veteran meteorologist exposes the global warming scam. And I have to tell you, it's widely held to be one of the most vehemently anti-climate change books ever written. And while it can be very painful for scientists to read things, I think it can be very constructive and even useful to read books like this and critically examine the arguments they put forward, because I used to just deny and ignore them. But so I read Sussman's book, and I identified some 77 distinguishable arguments. And I think it's only fair and right to acknowledge that despite Sussman's aggressively contrarian disposition, that there were arguments put forward in the book with which I largely agreed, and all 3 of them are worth noting. And while not technically a climate argument, I agreed with Sussman's opinion of the fans of the Minnesota Vikings. On page 30, Sussman observes that by virtue of wearing horn hats and proclaiming that their quarterback is an ancestor of Eric the Red, these people might be truly certifiable. I also agreed, but only partially, with Sussman's argument on page 118, that the shrinking of Lake Chad is not necessarily entirely caused by global warming. Irrigation overdraft is a contributing factor to climate change impacts. But Sussman and I are in absolutely full agreement with respect to his argument numbered 39 on page 105, which makes the claim that the movie Day After Tomorrow does not accurately portray current climate knowledge or accurately represent possible future climate change scenarios. And he's right. Climate disaster movies have in fact caused a tremendous amount of confusion about how climate actually works. So what I'd like to do now is look at some of these movies and see what they say about climate change. And I want to try to show along the way where the science has been bent out of shape for the purposes of entertainment. And the reason to do this is so we can understand really what's happening to climate and what the impact is going to be on where and how we live here in Canada. Day After Tomorrow was a smash hit in what's increasingly being called a science fiction genre called disaster porn. I thought that was really good. I call it cli-fi, but this film was made in 2004 in Toronto and Montreal, and when adjusted for inflation is the highest grossing Hollywood film ever made in Canada. And the film depicts the catastrophic, I don't know if most of you have probably seen it, but it depicts the catastrophic effects of global warming in a series of extreme weather events that usher in global cooling that leads to a new ice age. So what happens is after a massive drop in ocean temperatures in the North Atlantic, scientists conclude that the accelerated melt of polar ice has started to disrupt the North Atlantic current, plunging the entire northern hemisphere into deep cold. And the situation, of course, worsens when the resulting storm system develops into 3 hurricane-like superstorms. And in the eye of each of these storms, the temperatures drop to 150 below zero, and everything the air touches immediately freezes. I thought immediately of Winnipeg. And this is pretty scary stuff, but the question you got to ask is it likely to happen? Well, not anytime soon, and certainly not at anything that, like the rate that we see the cooling occur in the film. And what would have to happen? What would be required to cause the shutting down of the North Atlantic current would be a disruption in what's called the Atlantic Meridional Overturning Circulation, or AMOC as it's called, sometimes referred to as the Global Ocean Conveyor Belt. And this is an important component of the global atmosphere ice ocean climate system. And what it does is it redistributes heat between polar and equatorial regions and among the Earth's ocean basins and atmosphere. And it also contributes to the sequestration of anthropogenic carbon by the global ocean. And while there was genuine concern, as you may remember, in the 1990s, that the rapid melt of the world's great ice caps and ice sheets might disrupt this global ocean conveyor belt and bring about abrupt cooling in North America, most of the recent research suggests that the chances of this happening in this century are low. But it also noted that all bets are off if we continue to alter the composition of our atmosphere, in which case the day after tomorrow might not appear nearly so laughable to future generations. So let's look at movies about another phenomena associated with rapid melt and of the world's ice caps, ice sheets, ice fields, and glaciers. And one of the truly frightening climate change scenarios is rapid and extreme sea level rise. And the film that tried to scare us most in this regard is Kevin Costner's 1995 epic Water World. And the setting of this film, if you haven't seen it, is somewhere in the distant future, maybe somewhere around 2500. And in the beginning of the 21st century, it appears that polar ice caps began to rapidly melt and the sea level began to rise hundreds of meters, covering every continent and turning Earth into a water planet. And remaining populations were subsequently scattered across the ocean in individual isolated communities consisting of artificial islands and barely seaworthy boats. And the plot of the film centers on this otherwise nameless anti-hero, the mariner, a drifter who sails around the Earth in this trimaran. So is this likely to happen? Well, not a chance. And the first problem with the movie, at least in scientific terms, is that even if you melted all the ice on the planet, there wouldn't be enough water to submerge the continents. So this is what North America would look like if all the ice in the world melted. And well, you might certainly want to pay attention if you lived in California or the Caribbean, in southern Texas, Louisiana, Florida, the Carolinas, New York, Boston, or Halifax. Well, everything's going to be fine in Ottawa, so you don't have to worry about this. So even in the unlikely event that the West Antarctic ice sheet melts, mean sea level rise would only be in the order of meters instead of inches, but that's not the end of the world. A far more immediate climate-related threat is the potential effect of sea ice melt on ocean acidification, which is now occurring at a rate that's 1,000 times faster than what occurs nationally. And because of this, the world's oceans are 30% more acid than they were in 1800. And by 2050, our oceans are expected to be warmer and 150% more acid than they were 2 centuries ago, with cascading effects on all marine ecosystems. And by mid-century, we can also expect the land surface to be warmer. So let's look at movies that have dealt with heat, all right? And heat waves in themselves have not been the subject of high-profile Hollywood movies because they can be devastating and drive people to the limits of their physical and emotional endurance. Heat waves have, however, been the backdrop of a number of very interesting movies, including Spike Lee's Do the Right Thing. And the plot of this 1989 film develops around racial tensions that explode into a riot in an urban American neighborhood during a heat wave. And what's interesting about this film is that it's more prescient than it might look. Heat waves annually kill people by the thousands in concentrated areas around the world. And over 4 months in the summer of 2003, 70,000 people died in 12 European cities of heat-related ailments. And this problem is not going away. Rising levels of urban heat are now seen to constitute the single greatest climate-related threat to human health globally. And urban heat waves now count for more deaths per year than all other forms of extreme weather events. And so we don't have to wait for the future for this, where it's already happening. And because of the heat island effect of dark surfaces, solar absorption combined with waste heat from vehicles, buildings, industries, and even from people itself, what you find is that cities can be 12 degrees Celsius higher in temperature than surrounding countrysides. And this is quite interesting because with what would only be moderately warm temperatures in surrounding rural areas, we've discovered that big cities can create their own heat waves. And I've noticed this. I've been in Toronto and it felt like Bangkok, you know? And heat-related deaths underscore the limitation of the human body to withstand extremes of heat, which explains why we probably wouldn't have done very well in the Jurassic. And it can be true that it's true that we can, as a species, survive surprisingly high temperatures, in part because our metabolism operates at 37 degrees Celsius, which is usually considerably warmer than most outside temperatures. But above 37 degrees Celsius, the body must cool itself through evaporation in the form of perspiration. And unfortunately for the very young and the very old and those with health problems, the human heart has to work harder in heat wave conditions to distribute water for cooling through perspiration loss, and keeping up with this loss requires constant hydration. And that's why, and I found this quite interesting, is that most of the deaths during a heat wave happen at night when sleeping people don't hydrate, and what happens is their core body temperature rises and their organs shut down and their heart stops. So that's why you see those things happening at night. And one of the major reasons big cities are so much warmer now than in the past is the loss of trees and other vegetation to development. So trees not only store heat-absorbing water, their canopies create shade that moderates these high temperatures. And once the heat island effect is generated, it's very hard to reverse that. It takes a lot of time and a lot of money. So what we see here is that as resilience to climate extremes becomes a design imperative, cities may have to make extensive changes to their land and water situations. And these heat waves, though, are not the only threat to cities. So let's look at what the new genre of disaster movies have done to play up our fears of big storms, like what we experienced in Toronto recently and Alberta in 2013. And I gotta tell you, there are some scandalously bad movies in this category. And the hands down all-time worst B movie on climate change is the film called Sharknado. And all right, anybody here want to admit to have seen it? No, of course not, okay? Now, the premise of this film is that climate change is going to cause more powerful storms which result in unexpected events. And in Sharknado, the unexpected event is a massive storm off the coast of Mexico that forms a tornado at sea that's so powerful that it sucks 20,000 sharks up into the sky. And this is really good. I'm sure you can see where this is going. The storm, of course, hits Los Angeles in all its fury. And the sharks fall out of the sky and in the ensuing flood take over the city, attacking people in their Beverly Hills homes, occupying their swimming pools. And oh, there's one scene, and they come shooting out of manhole covers to eat unsuspecting pedestrians whole. You've got to see it. The film was so bad they made a sequel. And as the film opens, the heroine of Sharknado, the first, April Wexler, and the fearless Finn Shepard are on a flight descending into New York when the pilot announces unexpected turbulence. And April looks out of the window of the 747 and notices a shark stuck to the wing. And inexplicably, sharks are soon in the plane. One bites off one of April's hands, and it just goes on from here. And she's in New York to promote her new book, How to Survive a Sharknado. And I should point out that the weather forecasters, check the weather forecasters in New York. They're predicting a monstrous storm. I guess in New York, as they say, shark happens. And as the film comes to a close, after Finn and April save the city, but after narrowly being crushed by the head of the Statue of Liberty rolling down the street, and they confront and then triumph over a river of man-eating sharks. Now, I just want to point out that the science in this film is somewhat questionable, and you might actually want to drink heavily before you watch it. Now, a far more credible but still widely exaggerated film on extreme weather events was the 4-hour television miniseries in 2005 called Category 7, The End of the World. And the premise of this riveting series is that storms of unexpected ferocity are not just battering but destroying cities around the world. And while television evangelists proclaimed the end times, a newly charged and powerfully motivated FEMA is determined to find out what's triggering the extreme events, because these are of a magnitude that they've never seen before. And of course, with the help of renegade scientists, you've got to have renegade scientists for this. That's the only ones qualified to do that. And the US Air Force, it's discovered that urban heat islands are shooting thermal columns upward into the mesosphere, creating openings down which the cold of near space is brought to the surface of the Earth, causing never before witnessed Category 7 storms. And just as this Dick Cheney figure is sucked into the whirlwind and the White House is destroyed by the superstorm, the day is saved. And of course, the solution is to shut down all of the thermal power stations around Washington. And besides saving FEMA's reputation, the film Category 7, I think, had absolutely the best line in it of all the disaster films that I've seen so far. This renegade male science sub-hero says the following to very beautiful and very intelligent renegade scientist sub-heroine: "You are an egghead, but deep down you have a redneck heart." And she says to him, "Stop pussyfooting around and kiss me." So what you get from this, it's still going to be hot stuff in a warmer world, all right? So the legitimate fear to which these films appeal is that we are experiencing an increase in frequency or intensity of extreme precipitation events, including heavy rains, damaging flooding, droughts, hurricanes, and tornadoes. Now, the really interesting thing about Category 7 was that it was shot in and around Winnipeg. And that in itself invites us to examine what the climate disaster genre has done to scare us out of our minds with the prospect of bigger tornadoes. Now, there's some great tornado movies. I love this one. "Well, Dorothy, this still looks like Kansas to me," you know? And don't you just love the bewildered look on that cow? You know, whoa, what's happening here? And Twister is a 1996 American disaster drama film starring heartthrob Helen Hunt and Bill Paxton as storm chasers researching tornadoes. And they're working to perfect a data gathering instrument they've called Dorothy, which they're trying to release into the funnel of a tornado during a tornado outbreak across Oklahoma. And of course, they're competing with the bad guys. Now, as scientists, you'll all love this. The bad guys are a better funded team. You know, they've got real funding. And of course, they've got a similar device. And the researchers finally get Dorothy launched, but the climax of the film is when they find themselves chained to an irrigation pipe, staring up to the vortex of a F5 tornado. It's really quite something. Now, I thought that was pretty good, but Twister was gripping, but it's nothing compared to Into the Storm, which came out last August. And computer graphics have come a long way in the last 20 years, so, and so has their understanding of tornadoes. So if you ever have a chance to see this movie, see it in a movie theater, because I was in the fourth row and I thought I was going to be sucked into the screen. So it's really something. And I think what's interesting too is that the tension in this film is not between teams of funded versus unfunded researchers, but between scientific data and intuition in predicting tornado activities. And all of this forgotten once they go into the storm. You've got to see it. So there's some really excellent scientific interpretation in this film related to how tornadoes form and might act in a more energetic atmosphere. But I think most of you will understand this. Like most Hollywood films, the producers just can't resist going over the top at the end. It's just way over the top. So this begs the question, well, where do we stand presently in terms of understanding tornadoes? Well, in terms of absolute tornado counts, the United States leads the list with over 1,000 tornadoes recorded each year, and Canada's a distant second with about 100. But trends are difficult to establish, as you know, because tornadoes are short-lived events, and we have limited and unreliable data from sparsely populated areas where they normally typically occur, and so it's not really sure what the trend is. It appears to be growing. But one thing that we do know, however, is that one of only 9 Category F5 tornadoes occurred in Ely, Manitoba on June 22nd, 2007. And there's no loss of life, but the F5 at Ely does remind us that Canada has its own tornado alley. And that tornado alley, as you know, comes right through here, comes right through southern Saskatchewan and Manitoba, and it does this little dance around Edmonton. I don't know if that's symbolic or not, but so what you see is that these trends are changing because we have now had, surprisingly, tornado warnings as far north as the Yukon. And also, I never thought this would happen in my life, but actually tornado warnings as far west as where I live in Canmore, and I thought you wouldn't have tornado formation in mountain areas. But that may be changed as this occurs. Now, I think that it's important to note that some researchers think we're entering a new era of Earth system disruption, which I talked about at length yesterday, called the Anthropocene. And if that's the case, then I want to point out that we have now the first of what will likely become the most iconic images of what that era is going to be like. And this image is at once scary, but it's also hopeful. Check this out. So on Saturday, July 5th, 2014, a young Saskatchewan couple they're having their wedding photographs taken on a rural road outside of Regina when a tornado forms in the background behind them and later blows down their reception tent and scatters the guests. And the bride characterized this brave new world in which we now live on Facebook. You'll love this. She says, "We captured a once in a lifetime moment and feel so lucky to have it as a memory of how even in such chaos you always have each other." So that's love in the Anthropocene, so that's not going away. So all the disaster movie plots aside, what's really happening out there? What can science tell us about this that we're not getting from newspapers, from television, or from blockbuster Hollywood films? Well, you don't need to be a scientist to figure out that the weather's all over the place. Rainstorms, ice storms, and snowstorms are paralyzing our transportation and electricity distribution systems. Both high and low temperature records are being broken everywhere. Cold snaps are persisting. Snow is falling in places and in volumes seldom witnessed before. Flooding's occurring widely. But even with this, we're not really clear. We are still unsure about the role of climate effects in this. So what can we actually say we know? So what I'd like to do now is to introduce some of the connected hydroclimatic effects that researchers have identified as threats to the stability of our weather system. So I don't have to tell anybody here about the global influence of polar sea ice, and 3 factors related to the extent and duration of Arctic sea ice have emerged as having tremendous significance to the lives of everybody in this room and everybody in the Northern Hemisphere, certainly. And the first is the potential effect of sea ice melt on ocean acidification, which I've described. The second is the amount of heat required to melt sea ice. And the third critical effect is the profound influence of Arctic cold on the stability of weather conditions further south and globally. And what we see is that polar ice is now seen as a thermostat that governs major weather patterns globally. And it's now feared that the decrease in the extent and thickness of sea ice could be the parameter that's feeding many of the increases that are concerned to us over climate change. And what we see is there's been a 75% decrease in the volume of Arctic sea ice in the past 35 years. And the loss of sea ice allows heat to warm the Arctic Ocean, which creates a feedback which melts more ice. And this is why the Arctic is warming 2 to 3 times faster than the rest of the world in all seasons. And the loss of Arctic sea ice and the reduction of the extent and duration of snow cover in the northern hemisphere are reducing the temperature gradient, the temperature difference between the pole and the tropics. And it's this gradient in temperature between the polar region and the warmer air to the south that very much influences the behavior of the jet stream. And observations of the jet stream have revealed that warmer atmospheric temperatures don't automatically transfer into to warmer weather. In a uniformly warmer and therefore more turbulent atmosphere, warm and cold fronts end up and persist in places in mid-latitudes where they weren't common in the past. And what appears to be happening is very interesting. You look at some of the new research that's occurring. What we've observed is that as sea ice melts, the Arctic warms, again reducing this gradient between temperature between the pole and the tropics, and as the Arctic warms, the air warms, it expands to take up more space in the atmosphere and begins to spill down the hill that is the world. And what happens as that happens, it moves toward the mid-latitudes, this thicker air turns right as the Earth spins and it creates the jet stream. And the influence of warmer Arctic air causes the west winds created by the jet stream to become weaker. And what you see here is weaker westerly winds are wavier. That's a tongue twister, isn't it? And it's the waviness of the jet stream that appears to have so much influence on weather at mid-latitude. So as the jet stream slows and waves become wider, weather patterns persist longer and do things we don't expect. So when we look at extreme weather events such as heavy rain and snowfall events and heat waves, we see generally very large jet stream waves. And one of the many things a slower, wavier jet stream did last year was to disrupt the polar vortex. And I love the polar vortex. It's got, instead of sharks, it's got polar bears in it. I think that's really quite something. And what you see here is that there are actually two elliptical or circular polar vortices, one usually over the Arctic and one over the Antarctic in their respective winters. And the latter is very stable, but in the Arctic, the vortex is a lot more variable. It's influenced from below by changing Arctic ice conditions and from above by atmospheric warming events. And during the winter of 2013-2014, both factors weakened these. And what you see is a weak vortex is much more susceptible to disturbance at its periphery by the polar jet stream. So instead of one consolidated vortex over the Arctic, there are developed four lobes with the cold circulation carried south in troughs in the jet stream. And one of these lobes, of course, descended over southern Ontario. And we could hear your complaining all the way from Alberta. And it's really interesting to note that what we're seeing is that changes in atmospheric circulation patterns are pushing major subtropical storm tracks toward the poles, and this is causing flooding of magnitudes that we're poorly equipped to manage. So what we might derive from this is that the Arctic is more of a bellwether of climate change disruption than we thought. As I said yesterday, one comment I heard was really good. You know, the Arctic is not like Las Vegas. What happens in the Arctic doesn't stay in the Arctic, and that's what we're seeing. And what we're seeing also is that what's happening hydrologically in much of the rest of Canada is mirroring what's happening in the Arctic. What we're seeing is that warming is causing the post-glacial hydrologic wealth of Canada to change form. Arctic sea ice is melting, permafrost is thawing, snow cover is diminishing in both extent and duration. And warming is also occurring in Canada's western mountains. Where I live, some 300 glaciers have disappeared in the last century in the Canadian Rockies alone. And this water, of course, doesn't disappear. Water doesn't do this. The warming generated by change in the composition of the atmosphere is absorbed by water. And what is also happening is liquid water is moving to a different place in the hydrosphere where it may not be available for us when we want it, as in the case of extreme drought, and also where under certain conditions the warming atmosphere's capacity to carry more water can also cause damage through flooding. And what this indicates to us is that the hydrologic cycle is accelerating. And what we're seeing is that warmer temperatures are causing changes in the rate and manner in which water moves through the global hydrologic cycle. And the algorithm upon which this assertion rests is one of the most basic fundamental principles of atmospheric physics. Warmer air simply holds more water, and the amount of water the atmosphere can hold increases by about 7% Celsius and about 4% per degree Fahrenheit. And we're also witnessing things that we haven't seen or haven't been able to recognize as such before, which is quite interesting. And these include this phenomenon I talked about yesterday, atmospheric rivers. And what's interesting is that these atmospheric rivers, these great rivers of water vapor aloft, have probably existed for an eternity, but it's only now because of satellite remote sensing do we know of their existence and their dynamics. And these corridors of intense winds and moist air can be 400 to 500 kilometers across and thousands of kilometers long. And they can carry the equivalent of 10 times the average daily flow of the St. Lawrence. So they're massive systems. And what is new is that we've discovered that atmospheric rivers derive their energy from the temperature gradient between the poles and the tropics, and their intensity derives from the Clausius-Clapeyron relation, and the warmer the air, the more water atmospheric rivers can carry. So atmospheric rivers produce flooding of the magnitude that we saw in Australia and Pakistan in 2010, and also may have influenced flooding here. We do know for sure that an atmospheric river broke rainfall records by 87% in the Kootenay-Columbia River region in British Columbia in 2012. But it was really 2013 that demonstrated that some regions may have crossed over an invisible threshold into a new hydroclimatic regime. But I want to point out that despite all of the attention it received, it wasn't spring flooding in Alberta that provided evidence of this transition. The Alberta flood was 1 in 42 to 45 year event. So that means that it's well within the natural variability that we've experienced since settlement. The problem there is that Calgary and Erie weren't ready for it. What's new, though, is that flooding throughout the northern hemisphere is not associated as much now with spring melt, but bigger summer and fall storms. Now, I don't have to tell you that. This is what Toronto looked like 2 weeks after the Calgary flood. And I remind you that losses alone were $1 billion. And this, however, I want to point out, the flooding in Ontario and Alberta in 2013 is nothing, just nothing compared to what the atmosphere is capable of delivering as a result of changing hydroclimatic conditions. What happened in Russia a month later is almost beyond imagination. It is truly the stuff of science fiction. What we had there and what we saw was the weakening of the European jet stream caused by reduced snow and sea ice cover led to the creation of a heat dome in northern Siberia. So they had this very profound drought, and in July hundreds of wildfires broke out that were so hot they melted the permafrost below the burning forests, creating methane releases from the thawing tundra that added fuel to the fires. And then in early August, in the midst of what was really becoming to resemble a virtual firestorm, 3 atmospheric rivers collided over the region and within 4 days created a flood that covered 1 million square kilometers. So you begin to see the massiveness of some of these systems. Then the flooding in Colorado that fall in September of 2013 is very interesting too, because it happened in the autumn, and it was quite independent of spring melt, which is, again, this is an indication that subtropical storm tracks are tracking poleward and the atmosphere is carrying more water. That storm was, even though it was the Front Ranges of the Rockies, was tropical in nature. And the state climatologist of Colorado, Nolan Deskin, noted that storm shattered all records for the most water vapor in the atmosphere. So I think the floods of that year offer us a glimpse into the wild weather that we might expect in a warmer hydroclimatic circumstance. So that takes us to this past year. And I talked a lot about this yesterday, but I'll just go quickly through this. The prairies miss a spring flood, and though it was close, so does Alberta. Then POW, the flooding comes not in association with the spring melt, but as a result of remarkably heavy rainfall and early summer storms. And in southwestern Manitoba, 50% of the land was covered by water, much of it in the form of floodwaters coming from Saskatchewan. And so what you see from this is that what were once loosely for problematically called 1 in 300 year events in the Great Plains have evidently begun to appear every 3 years. And this isn't the only place that this is happening. So you look at what happened in Kamloops on July 24th, where they had 25 millimeters of rain, as much rain as they normally get in a month, and it fell in 20 minutes. And this is another interesting phenomena that we're seeing. There's these tremendous cloudbursts, but also seeing flooding and drought events in the same basin in the same year. And that's a very interesting problem. Then, of course, you had Burlington, I don't have to tell you about that, where you had 200 millimeters of rain, as much as falls in 2 months, and roughly the time it takes for your morning rush hour. And then you know what's happening in Toronto. Our neighbors weren't spared last year either. As August progressed, you had similar flooding conditions in Detroit, Cleveland, and Long Island. A week later in Winnipeg, and after that in Steinbeck and Niverville in southern Manitoba got hit with 120 millimeters of rain. That's nearly 5 inches of rain in an overnight storm that overwhelmed flood mitigation systems that had been put in place after flooding in 2002. So this gives you an indication of the implications for infrastructure. How do you design for that? And even though the Maritimes doesn't make the news often, they have a lot of flooding issues there too. And the flooding occurred there in December of this past year drew attention to the fact that Nova Scotia's relied on federal disaster relief for 14 of the last 15 years. And you already see named winter storms that which simultaneously bring heavy snow and flooding, as we saw on the eastern seaboard in January. But I have to tell you that I know that some of you have traveled very widely in this country also and will have your own stories about wild weather. I have difficulty imagining more turbulent weather than they already have in Newfoundland. My experience there is winter storms are more like winter hurricanes and blizzards. So I was in Gander last March, you know, and my hosts are going, you got to get out of here. You got to go home. You got to get out of here. And I'm going, well, geez, what? I must have said something wrong. No, there's a storm coming. And I managed to get the last flight out of Halifax before it happened. But what happened there was unbelievable. 50 centimeters of snow fell in some places, and there were wind gusts of up to 160 kilometers an hour. And I got to Toronto, and I was watching on the television weather what was happening. And one man was interviewing another. They had their hoods up and everything. He had the microphone out, and they both blew off camera. They were just gone. And then there was nothing there. Then you see the top of one of their hoods kind of is crawling back into the scene. So and there's a lot of wild weather out there, and we're certainly seeing it in Canada. So what is this weather trying to tell us? Well, I think what water is trying to tell us is that the hydrologic game is changing in fundamental ways. And we know also that hydrologic conditions on this planet certainly have always been changing. And we've been very fortunate to have a century or so of relative hydroclimatic stability. But that era, and you can imagine how well this goes over in Alberta, is over. The long-term hydrologic stability of the climate we experienced in the past is not going to return during the lifetime of anyone alive today. So what does that mean? Well, it means that given the most basic laws of atmospheric physics, suggests that what we're going to get is what we see. Predicted rises in temperature between 2 and 6 degrees Celsius will result in further amplification of the hydrologic cycle by up to 15% to 40%. And that change is not going to go away. In order to give even partial gain even partial rain over the hydrologic cycle, we're going to have to enlist all the help that nature can provide us. And I think there's some real power in realizing this, for it's at the local level where we live that we have the most power to affect change and to act most effectively in service of the common good by restorative development and protecting and restoring environments. But the third game changer is that we have to recognize that sooner or later we're going to have to address the root issue. And it's very difficult to adapt if you don't know what you have to adapt to. So unless we want our future to continue to be a moving target, sooner or later we have to confront the root cause of our changing hydrology, which unfortunately remains a subject that few want to talk about in meaningful terms, at least where I live in Alberta. So I want to make this clear, however. The sky's not falling. It's not the end of the world. The problems hydroclimatic change is bringing in its wake, however, are not going to go away. And what I like to tell people in Alberta that we should not expect a Hollywood ending. Wishful thinking and last-minute heroics are not likely to get us out of this one, but thoughtful and timely local action will. And I, for one, are counting on people like you who care to save the day. I'm counting on you to be stars. Thank you very much.